Hello everyone, this is Arnold Rangakuramia from Kisembo Academy, helping you manifest academic excellence, and in today's video, we'll be exploring the following.
We'll be looking at everything about circles, from the circumference of a circle, perimeter of a circle, area of a circle. Then we'll dive deep into the likes of angle properties of a circle, the tangent properties of a circle, and the chord properties of a circle. Right in front of us is a diagram of a circle. In this circle, we have the radius, what we call the radius. The radius is simply the line that connects one point to the circumference from the center, as we all see. It's connecting this point from, this is the center of the circle, and it's connecting it to the circumference. That's what we're calling the radius. We have what we call the diameter. Call it the longest chord. It is simply the line that connects 2 points on the circumference and it passes through the center. Then we have what we call the chord. A chord is simply a line that connects any 2 points of the circumference. So it can run from here up to there, or it can run from here up to there. Any 2 points of the circumference is connected by a line we call a chord. And of course, the longest chord is what we call the diameter, because it connects the 2 points of the circumference, but it passes through the center. So the diameter is the longest chord of a circle. Right here we have what we call the segment. Of course, a segment is just a portion of the circle that is divided by a chord. When you draw, we have what we call the arc. An arc is simply a portion or part of the circumference. When divided into two, you find that we have what we call, the smaller portion is what we call the minor arc. Then this other part, the bigger one, is what we shall call the major arc. Then we have what we call the circumference. The circumference is simply the distance around the circle, or call it the perimeter around the circle. Then we have what we call the sector and the segment. Now a segment is when a chord divides a circle into two, what it creates is a segment. And by definition, a segment, we can call it, it's a portion that is cut off by a chord. Likewise, a sector is a portion of a circle found between two radii. Now, when a chord cuts the circle into two segments, there is the smaller portion and the larger portion. Likewise, when these two radii cut off a portion of the circle, like we are seeing here, we have the smaller portion and then the larger portion. We said that a sector is a portion of a circle that is found between two radii. So it means that this portion, the smaller portion, is what we are calling the minor sector, and the larger portion, we call it the major sector. We said that a segment is a portion that is cut off by a chord. The larger portion of the segment, which is this one, is the major segment, and then the smaller portion is the minor segment. Thanks for tuning in. This is Kisembo Academy. In this tutorial, we shall look at the circumference of a circle, we shall look at the area of a circle, we shall look at the perimeter, and other basic calculations around the circle. We said that circumference of a circle is simply the distance moved around a circle, and we'll go straight into calculations. Find the radius of a circle whose circumference is 44 centimeters. Now, there's formula for circumference of a circle. Circumference is equal to pi d, or circumference is equal to 2 pi r. Of course, these two times r is equivalent to d, because we know that the distance or the diameter of a circle is equivalent to 2 times radius. So when we replace this d with 2r, it becomes 2 pi r. So to find the radius of a circle whose circumference is 44 centimeters, we simply put that formula that the circumference of a circle is given by 2 pi r, and we know that it's going to be 2 times pi. Pi is 3.14, or 22/7. times the radius. Now they are asking us to find the radius of the circle whose circumference is 44 centimeters. So the circumference is 44. Then we get our value of r. The diameter of a circle is 21 centimeters. What is the circumference? So we know that the formula for circumference, C is equal to pi d or 2 pi r. So they want the circumference of a circle. So our value of pi is 22 over 7 or 3.14. Multiply that by the diameter. They are telling us the diameter of the circle is 21 centimeters. So it means that by 7 once, by 7 thrice, 3 times 22 is 66 centimeters. So the circumference of that circle is 66 centimeters. Chimba moves around the circle of diameter 56 centimeters 50 times. What distance does he move in meters? So we are being told that Chimba is going to move around the circle 50 times. So this is the circle they are talking about. Chimba moves around this circle whose diameter is 56 centimeters. The diameter is 56 centimeters. But he moves around it 50 times. So it means he's going to move around this circle circumference 50 times. So what distance does he move in meters? So what we do here, we are going to first find the circumference of this circle. After finding the circumference of that circle, then if we are to find the distance this guy moves, it means you're supposed to multiply that circumference we get by 50 times, because he moves around the circle 50 times, and that will be the answer we will get. So since to get the circumference, we know that circumference of a circle is going to be equal to pi d. Remember, this 56 is diameter, so this distance is from here to there. So it's pi d, which is going to be 22 over 7 times the diameter, which is 56, and it is in centimeters. So our answer here is the circumference of this circle is 176 centimeters. So 176 centimeters is the distance that is moved around this circle in one revolution or one round. But Chimba moves around the circle 50 times. So to find the distance he moved, it means that we're supposed to multiply this by 50. So to get the total distance moved when he moves around 50 times, we shall get 8,800 centimeters. But then the question requires us to find the distance he moves in meters. So it means we're supposed to convert this to meters. And when we convert this to meters, we divide this by 100 and we shall end up getting 88 meters. Next question. Martha has to run a race of 440 meters around a circular field of radius 35 meters. So this is the circular field, and it is having a radius of 35 meters. Martha has to run around this field. How many times does she go around the field? So she's running this distance but around this field, but we do not know how many times she runs around it. So what we do here, we need to first find the distance, that how long will he run if she runs around it once. Then if we know how long the distance is when she goes around it once, then we will be able to find how many times she will be able to run around it when we in at a race that is that much. So finding how long the distance around the field is means you're supposed to find the circumference of this circle, or the circumference of the field. And we said that circumference of a field is going to be, in this case we can say pi d or 2 pi r, but since we have radius, let's use 2 pi r. That's going to be 2 times pi, which is 22 over 7, times the radius of the field, which is 35. And then we shall end up with our answer. The distance around the field is 220 meters. But Martha runs a race of 440 meters. So for us to be able to know how many times she goes around this field means you're going to get the total distance moved around in this distance. The total distance she runs, divide that by the distance moved around in one field. Or we can do it simply like this. That when he runs around one time, the distance he's supposed to cover is 220 meters. If he moves around, if she's to move at 440 meters, how many times will she have moved? So we do not know how many times. We call that x, and then there we cross multiply. When we cross multiply, x times 220 is going to give us 220. X is giving us 440 times 1, which is 440. When you divide both sides by 220, we shall end up with x giving us 2 times. So he has to move around 2 times. Now let's try and find the perimeter of these shapes. Now before, we've been doing perimeter of a circle, or call it the circumference of a circle, and we said that circumference of a circle is pi d, or it is 2 pi r, where r stands for the radius and d stands for diameter. Pi is simply a constant, which is equivalent to 3.14 or 22/7. Now when we are trying to find the circumference of a circle, this pi d actually represents the entire circumference, the arc. When I move from here, I go around the circle up to that point. That is the distance that is being represented by this formula pi d, or 2 pi r. Now if we are being asked to find the perimeter of these following shapes, you realize that these shapes are not full circles. Let's look at this one. This is a full circle. For me to find the perimeter of this circle, I'll say circumference of this is going to be equal to 2 pi r, which is going to be 2 times 22/7 times the radius, which is 7. And the perimeter here is 44 centimeters. And so it means that this 44 centimeters is the distance moved around the whole circle, or the curved part of the circle. Now when it comes to finding the perimeter of this shape, first of all, this is a quarter of a circle because of that 90 degrees. So it means that the circumference of this circumference is going to be equal to a quarter of 2 pi r. A quarter of 2 pi r. But now this a quarter of 2 pi r is the distance that is covering a quarter of this curved surface. It means that it is this a quarter 2 pi r is representing the distance from that point up to that part, only excluding this, excluding that. So if the circumference, or the perimeter around this whole object is going to be a quarter of 2 pi r, which is the distance from here to there, then if we are to find the remaining part, it means it's going to be plus that plus that. This is the radius, that's the radius. So it's going to be a quarter 2 pi r plus the radius plus radius. So it continues. It's going to be a quarter times 2 times 22/7 times the radius, which is 7, plus the radius, which is r, and r, which is plus 7 plus 7. And of course the answer we shall get there is 11 plus 7 plus 7, because the same happens to this. We shall calculate this right here, this circle. If you are to find the perimeter of this circle, it means that we are going to find the distance of that curved surface, then plus the distance from here to here. This is the diameter of the circle, which is 7 plus 7. This is the whole of this is 14. So this is going to be this is half of a circle. So it's going to be a half of the circumference of the curved surface. A half times 2 pi r. Now a half times 2 pi r accounts for half of the curved surface plus the diameter. That is plus the diameter, to find the distance around the whole, which is the perimeter. So it's going to be a half times 2 times 22/7 times radius, which is 7, plus the diameter, which is 14. And you will of a circle. Now the formula for area of a circle is pi r squared, as simple as that. And let's look at some of these examples here. We have a full circle here and we are required to find the area. The area of this circle, this being a full circle, area is going to be pi r squared. We said that pi is a constant which is equivalent to 22 over 7 of 3.14 times r, which is 7 times 7. When we cancel both, we find our answer 22 times 7, giving us 154 centimeters squared. That's the area of this circle. Let's get to this circle. Find the area of that. We recognize that that is 3/4 of a circle, because a quarter of it is eaten away. So it means that to find the area of this circle is going to be 3/4 of the whole area. The 3/4 times the formula to get the area of that. So area of this is going to be equal to 3/4 times pi r squared, which is the area of the circle, which is going to be 3/4. Multiply that by 22 over 7 times radius, which is 7 times 7. So this cancels with that. When you compute the rest of this, you end up getting your answer as 115.5 centimeters squared as your answer. Now sometimes we are able to know that this is a quarter because this, remember, all angles at a point are equivalent to 360 degrees, and if we are having 90 degrees here, it means that the rest of this whole bit is 270, because 360 minus this 90 degrees is giving us 270 as the other part of the circle. So for us, it's to get this 3/4 as the fraction of this circle, it was as simple, it was the same as saying that the fraction, this fraction, is going to be 270, divide that by 360. And 270 divided by 360 gives you 3/4. And so, having known the fraction of this, that is how we started it off, by saying it's 3/4 of the whole circle. Looking at this other formula, this other circle, sector, to find the area of this sector, the area of that sector is going to be, if you find that this sector is just only having 30 degrees in between. So now what is 30 degrees of the whole circle? So the area is going to be 30 degrees over 360 degrees of the area of the whole circle, which is pi r squared. And that is going to be giving us 30 degrees over 360. Multiply that by pi, which is 22 over 7, times the radius, which is 7 times 7. And when you compute all that, you're bound to get 12.8 centimeters squared as the area of that sector. Today we get to look at the angle properties of a circle. Thanks for tuning in. Now there are various angle properties of a circle that are required to be held to memory, because when we are dealing with numbers that are involved with trying to find angles that are missing within circles, you interpret such questions using the properties. Let's look at the first property here. We have angles that are subtended at the circumference. Now these are the angles we are talking about that are being subtended at the circumference. You find that this angle Z is subtending this angle Z to the circumference. This angle Y is subtended to the circumference by this same chord. Then also this same chord subtends the angle X to the circumference. And we are saying that angles that are subtended to the circumference by the same chord are equal. So in this case, the value of X, Y, and Z, all these angles are equal. For example, if you look at this number here, we have angles X and we have angles Y, and we are required to, what is the value of X and Y? But if you look at it here, If you look at it, we are having a chord passing through here. This chord is subtending that angle y. It is the same chord subtending the angle 32. It's the same chord subtending the angle x. And since from that property that the angle subtended by the same chord to the circumference, all those angles are the same, it means that the value of x is also 32 and the value of y is also 32. So x and y, they are each 32. Getting to this here, we're required to find the values of a and b. If you look at this angle A, it is subtended by this chord. This chord subtends that angle to the circumference. Likewise, this same chord, it is subtending another angle to the circumference. So meaning that if this is 40 degrees, this is also 40 degrees, looking at the property we just looked at. It's the same with angle B. If you look at this angle B, it is subtended to this circumference by that chord, like that. And this same chord subtends another angle to the circumference. So if this angle is 25 degrees, it means that B is also 25 degrees. An angle that is subtended at the circumference by the diameter is equal to 90 degrees. Remember, when we were introducing chords earlier, we said that the diameter is the longest chord. And this is the longest chord that passing through the center of the circle. It is the diameter. So any angle that is subtended by the diameter to the circumference is 90. Subtended by the diameter to the circumference is 90. So meaning even if I had drawn another angle subtended to this diameter like that, this is 90 degrees, or another subtended by the same chord, this is still 90 degrees. In this next property, we are looking at an angle subtended by the same chord. One angle is subtended to the center, and the other angle is subtended to the circumference. And we are saying that if we are having an angle that is subtended to the center, if the angle subtended to the center is 2x, so it means that the angle that is subtended by the same chord to the circumference is going to be a half of that. Just like we are seeing a chord here, it is subtending a certain angle to the center, and this same chord, it is subtending this same chord is subtending another angle to the circumference. So it means that if this angle that is subtended to the circumference is y, then it means the one that is subtended to the center is twice that one, just like we've seen here. So the property is simple, that an angle subtended by an arc or a chord at the center is twice the angle subtended at the circumference by the same arc or chord. Let's do some examples to illustrate this. If you look at this, for example, we have 24 degrees there, and we are required to find the value of A. Now the value of A here is going to be, we remember that this is the same chord. It is subtending 24 degrees to the circumference. It's subtending the same, another angle at the center. So meaning that this angle is going to be twice that one. So the value of A here is going to be 2 times 24. And it will be 48 degrees. Same here. The value of X here is going to be 2 times 17. And that is going to be 140 degrees, using the property we have just talked about. We need to find the value of y, but we see that we are having the same chord here. It is subtending 30 degrees there, and the same chord is subtending an angle y at the circumference. We know that this is twice that by the property we just saw. So it means that to get the value of y is going to be give us 130 degrees, divide that by 2, and so our answer is going to be 6, 5. If you look at this circle, we're having an angle 60 degrees here, and we're having an angle x there. We need to find this angle x, but you realize that it is all subtended by the same chord. We have this chord. This chord, you see, is subtending an angle at the center, and the same chord is subtending another angle to the circumference. So we know that this angle here is twice that one by the property we just saw. So it means the value of x here is going to be 60 times 2. So our value of x there is going to be equal to 60 times 2, and so the answer is 120 degrees. Cyclic quadrilaterals. A cyclic quadrilateral is simply an image. It's simply one which has all its 4 vertices at the circumference. So if you look at this, it's having its vertices all touching the circumference of a circle. When you're having an object whose vertices are touching all the circumference of a circle, then that qualifies to be a cyclic quadrilateral. The condition is that those vertices must touch the circumference of the circle. And opposite angles in a cyclic quadrilateral add up to 180 degrees. So meaning that y plus z is equal to 180 degrees, x plus r is equal to 180 degrees. As simple as that. Looking at some examples to illustrate this point, we need to find the value of a. But this is a cyclic quadrilateral because all its 4 vertices are touching the circumference of the circle. So it means that the value of a here is going to be equal to this plus that is 180 degrees. So it means to get the value of a is going to be 180 degrees minus 118. And our value of a will be 62 degrees. Likewise here, we have a cyclic quadrilateral. Its vertices are all touching the circle's circumference. So to get the value of x, we know that the opposite angles of a cyclic quadrilateral add up to 180 degrees. So x plus 65 is equal to 180 degrees. So meaning our value of x is going to be 180 degrees minus 65. And our answer will be 115 degrees as our answer. So likewise, looking at this other cyclic quadrilateral, y plus 115 degrees is supposed to be equal to 180 degrees. So we shall still say y plus 115 degrees is equal to 180 degrees. Y will be 180 degrees minus 115 degrees. So we shall end up with our value of y as 65 degrees. If one side of a cyclic quadrilateral is produced, the external angle formed is equal to the opposite interior angle. This is one of the sides that has been produced, so it means that this exterior angle should be equal to the interior angle there. Likewise, if I produce this line, it means that if this is my angle y, it means that it's supposed to be equal to the opposite interior angle, which is that y. In the same way, if I produced this line like that, and this is my value of z, that is the angle. So if this line is produced and that's value of z, that's the angle, the exterior angle, this exterior angle is equal to the opposite interior angle, which is that. So that is one of the properties, that's the last property. We call it the alternate segment theorem. Now, before, remember we said that when a chord divides a circle into two, a chord divides a circle into what we call segments. We have what we call the major segment and the minor segment. Now, here we are looking at the alternate segment theorem, and it simply states that if a chord is drawn with one end at the point of contact with a tangent, this is the chord we are talking about. If one end of the chord is at the point of contact with this tangent to the circle, the angle between the chord and the tangent, the angle between this chord and the tangent, which in this case is x, is equal to the angle in the alternate segment. So this is the chord we are talking about. When you look at this chord, it divides this circle into this segment and the other segment. So it means that if this is the segment within which the angle x is, it means the alternate segment is this other one. And the angle that is in this other alternate segment is equal to that angle. This is called the alternate segment theorem. By alternate segment, to make it clearer, this is what I mean. If you look at this chord, it is dividing this circle into the major segment and the minor segment. If you look at this circle, this chord divides in the circle into the major segment and the minor segment. So if the angle is located between this tangent and the chord, if that's the angle x, it means the alternate segment we are talking about is the shaded region. Likewise here, the alternate segment is the shaded region, because in this other segment, that is where the angle is, and this is the angle that is between the chord and the tangent. If you look at this value of x, this is the angle x. The angle in the alternate segment is that one. Likewise, this is another chord dividing that segment and this segment. So if the angle is between the tangent and the chord, which is y, it means the other angle in the alternate segment will be that one. A tangent is a straight line that touches the circumference of a circle at a point. In this tutorial, we are going to look at tangent properties of a circle. This is Kisembo Academy, and thanks for tuning in. Looking at the diagram on your screen, you see a line AB. This line AB is touching this circle at a point X. Now this line AB touching this circle at a point X is what we are calling a tangent. Tangent, we said, is a straight line that touches the circumference of a circle at a point, and that is the point we are talking about. This line is touching this circle at that point X. So today let's get to explore more tangent properties of a circle. When we are having a tangent like this one touching just a part of the circle's circumference, if this is the circle's center, then the line drawn between the circle's center to touch the circumference of the circle, which is the radius, is going to make an angle of 90 degrees with that tangent. In other words, when the point of contact between the tangent and the circle will be making an angle of 90 degrees with the radius. We have some other properties that we need to explore here. Consider two tangents. We have BT here. BT is a tangent. And we are also having AT. It is also another tangent. These tangents, when they meet the circle at these points, they connect with the circle at a point whereby they make 90 degrees with this radius. So it means that this is 90 degrees and that is also 90 degrees. So when you realize that, as these tangents make these 90 degrees with the radiuses of this circle, they are going to make these tangents also subtend angles at the center. We have angle y here and an angle y there. The line that is joining the center of the circle to the common point where these tangents are meeting outside the circle, this line bisects this angle. And by bisecting, I mean that it's going to divide this angle into two. So this line that is connecting these two tangents from the circle center to the point where these two tangents meet outside the circle divides this angle into two. So meaning that if this angle is x, this one is also x. Likewise, this same angle is also going to divide this whole angle into two. That is why you see that when this is y, that is also y. So this is how it is explained in our write-up, that length BT is equal to length of AT. So if you look at this tangent BT, the length from here to here is the same as the length from here to there. Angle BTO, which is this one, BTO, which is that one, is the same as the angle OTA, which is that one, because this line bisects this angle into two. It bisects this angle, so it divides it into two. So if we are having this line being equal to that line, we are having, this is the radius of the circle. It is equal to that radius of the circle. So these two are the same. These two lines are the same. Then you're having this angle being equal to that angle. And then you're also having this angle y being equal to that angle y. It simply tries to mean that this right angle triangle is the same as that right angle triangle. And as such, this middle line we are talking about is simply acting as a line of symmetry. As we proceed, we'll be interpreting some of these numbers using some of these properties. If you look at this number, we are being required to find the value of z, the value of x, and the value of y. Now, we know that these ones are tangents. And you know that when a tangent is going to meet a circle, the radius, the angle between the radius and the tangent is 90 degrees. So, by that knowledge, we already know that the value of y here is 90 degrees. And the value of x here is also 90 degrees. Now, what's the value of z? There are two ways you can find the value of z. First of all, this is a quadrilateral. This. And we all know that a quadrilateral, the total angle sum of a quadrilateral is 360 degrees. So it means for us to be able to get the value of z is going to be x plus y plus z plus 35 degrees is equal to 180 degrees. 360 degrees. So it means that's our working, that z plus 90 plus 90 plus 35 is equal to 360 degrees. We make z the subject of the formula. It becomes 360 minus the rest of all this comes that side. And we get our value of z as 145 degrees. Now we can either get it like that, or we can choose to use another way. It means using our property before, we can choose to divide this into two. Remember, we said that this acts like a line of symmetry. This is a right angle triangle, and this right angle triangle is the same as this right angle triangle. We said that this line bisects this. It means it divides this angle 35 into 2. So if it's dividing it into two equal parts, so if this was originally 35 degrees, dividing it into 2 means that this is going to become 17.5, and this one is also becoming 17.5 degrees, these two angles. So it means that this value of z is also being divided into two equal parts, into this and that. So if we are to extrapolate this right angle triangle here, and we are to say that we have extrapolated this, so our value of y here is 90, which is this part, 90. So this is our value of z. It has been divided into two. Let's call it theta, our value of z. Then our value 17.5 is up there. So if you are to get 17.5, now our task is to find the value of z. But you know that to find the value of z, we can first get the value of theta. We know that when we get theta, we will multiply this value of theta by 2, so that we get the whole value of z, since the value of theta here is the same as the value of theta the other side. So to get this value of theta, we know that this is 90, and we know that the total angle sum of a triangle is 180 degrees. So this is simply going to be theta plus 90 degrees plus 17.5 should give us 180 degrees. So if it is to give us 180 degrees, it means our value of theta there is simply going to be 180 degrees minus all this, minus 90 plus 17.5. And we shall get our value of theta as, now 72.5 is just half of that value of z. We want the whole value of z. So it means that for us to get the whole value of z, it means that z is going to be 72.5, multiply that by 2. And when you multiply that by 2, you will end up with 145 degrees. We have another example to work out here. We have, this is a tangent, that's also a tangent. We are required to find the values of q, the value of r, and the value of p. Now, straight up, from here we know that the line that is connecting this center of the circle to the point where these two tangents meet, it divides this into two, or it bisects this angle. So if it's bisecting this angle according to our earlier property, it means that the value of q and the value of r is the same. Likewise here, this angle is also being bisected, or it's being divided into two equal angles. So if this angle is 82 degrees, it means that the value of p is also 82 degrees. So straight away here we know that the value of p is 82 degrees. And now what about the value of q and r? We know that this being a tangent, it meets this at that point at 90 degrees. If it means at 90 degrees, it means that we shall take interest in just one of those triangles. And you know that the total angle sum of a triangle is 180 degrees. So it means it's going to be 90 degrees plus 82 degrees plus r is equal to 180 degrees. So it's 90 plus 82 plus r is equal to 180 degrees. So our value of r is going to be 180 degrees minus 90 plus 82. And we shall get our value of r as 8 degrees. So when we get the value of r as 8 degrees, it means that even our value of q will be 8 degrees. By that knowledge, we already know that the value of y here is 90 degrees, and the value of x here is also 90 degrees. Now what's the value of z? There are two ways you can find the value of z. First of all, this is a quadrilateral. This. And we all know that a quadrilateral, the total angle sum of a quadrilateral is 360 degrees. So it means for us to be able to get the value of z is going to be x plus y plus z plus 35 degrees is equal to 360 degrees. So it means that's our working, that z plus 90 plus 90 plus 35 is equal to 360 degrees. We make z the subject of the formula. It becomes 360 minus the rest of all this comes that side, and we get our value of z as 145 degrees. Now we can either get it like that, or we can choose to use another way. It means, using our property before, we can choose to divide this into two. Remember, we said that this acts like a line of symmetry. This is a right angle triangle, and this right angle triangle is the same as this right angle triangle. We said that this line bisects this. It means it divides this angle 35 into 2. So if it's dividing it into 2 equal parts, so if this was originally 35 degrees, dividing it into 2 means that this is going to become 17.5, and this one is also becoming 17.5 degrees, these two angles. So it means that this value of z is also being divided into 2 equal parts, into this and that. So if we are to extrapolate this right angle triangle here, and we are to say that we have extrapolated this, so our value of y here is 90, which is this part, 90. So this is our value of z. It has been divided into 2. Let's call it theta, our value of z. Then our value 17.5 is up there. So if you are to get 17.5, now our task is to find the value of z. But you know that to find the value of z, we can first get the value of theta. We know that when we get theta, we will multiply this value of theta by 2, so that we get the whole value of z, since the value of theta here is the same as the value of theta the other side. So to get this value of theta, we know that this is 90, and we know that the total angle sum of a triangle is 180 degrees. So this is simply going to be theta plus 90 degrees plus 17.5 should give us 180 degrees. So if it is to give us 180 degrees, it means our value of theta there is simply going to be 180 degrees minus all this, minus 90 plus 17.5, and we shall get our value of theta as, now 72.5 is just half of that value of z. We want the whole value of z. So it means that for us to get the whole value of z, it means that z is going to be 72.5, multiply that by 2. And when you multiply that by 2, you will end up with 145 degrees. We have another example to work out here. We have, this is a tangent, that's also a tangent. We are required to find the values of q, the value of r, and the value of p. Now, straight up, from here we know that the line that is connecting this center of the circle to the point where these two tangents meet, it divides this into 2, or it bisects this angle. So if it's bisecting this angle according to our earlier property, it means that the value of q and the value of r is the same. Likewise here, this angle is also being bisected, or it's being divided into 2 equal angles. So if this angle is 82 degrees, it means that the value of p is also 82 degrees. So straight away here we know that the value of P is 82 degrees. And now what about the value of Q and R? We know that this being a tangent, it meets this at that point at 90 degrees. If it means at 90 degrees, it means that we shall take interest in just one of those triangles. And we know that the total angle sum of a triangle is 180 degrees. So it means it's going to be 90 degrees plus 82 degrees plus R is equal to 180 degrees. So it's 90 plus 82 plus R is equal to 180 degrees. So our value of R is going to be 180 degrees minus 90 plus 82. And we shall get our value of R as 8 degrees. So when we get the value of R as 8 degrees, it means that even our value of Q will be 8 degrees because this value of Q and R are the same. We can try and find the length of the tangent D. We're having a tangent here. TA is a tangent. This is a tangent. OT is 12 centimeters. Find the length of AT. So we need to find the length of the tangent from this point to that point. Now to find the length of the tangent, AT is still going to be the same as we've been doing it before. To find the length of AT, we know that this is a right angle triangle. And we know that right angle triangle here, it is 90 degrees. And let's rewrite drawing this. If this is our right angle triangle, in this right angle triangle, this is our value of A, which is that, then T is here, then O is right here. This here is 6 centimeters, here it is 12 centimeters, and they want us to find the value of AT. Now to find the value of AT, we shall use Pythagoras theorem, which is 8t squared plus 6 squared is equal to 12 squared. So it means that our value of 8t squared is going to be equal to 12 squared minus 6 squared. And we shall end up getting our value of 8t being equal to the square root of 144 minus 36. And when we compute that, we shall end up with our value of 8t giving us 10.4 centimeters. Our next question is asking us to get the angle AOT. AOT. They want us to find that value. Let's name it theta. So if you're to transfer that to our little diagram here, they want us AOT, they want us to get the value of theta. Now for us to be able to find the value of theta, we are going to use trigonometry. And in this case, we shall be finding the cosine of that angle theta. So the cosine of this angle theta, cosine of our angle theta is going to be equal to the adjacent, which is 6 centimeters, over the hypotenuse, which is 12 centimeters. And of course, cosine of theta is equal to a half. To find the inverse, the cos inverse of this theta, of this half, we are going to get the value of theta as 60 degrees. And so that is the answer to that part. Then Roman 3, they're asking us to find the area of the shaded region. This is the area, the shaded region they are talking about. To find the area of this shaded part, therefore, let's look for the, first get the area of the triangle. Area of a triangle, we all know that area of a triangle is a half times base times height. And the area of this is going to be a half times the base. Now this is the triangle. The base can be one of these two, as long as these two lines that are meeting at 90 degrees. So let's take our base to be 6 centimeters. So it's going to be a half times base, which is 6 centimeters, times the height. This will be our perpendicular height, which we already got as 10.4 centimeters. So our answer there will be 31.2 centimeters squared. So this is the area of the whole triangle. Now we find the area of this sector, the unshaded part. So the area of this sector is going to be, now this value of theta we got, remember, we got this value of theta as 60 degrees. So the area is going to be 60 over 360 degrees times the area of the circle, so which is pi r squared. So that's going to be 6 over 36 times 22 over 7 times the radius, which is 6 times 6r squared. So we find that the area of this sector is going to be 18.85. centimeters squared. Now the question requires us to find the area of the shaded part. So it means we are going to get the area of the whole thing, which is 31.2 centimeters squared, subtract the area of the unshaded region, which is 18.85. So when you get 31.2 centimeters squared minus 18.85 centimeters squared, the area of the shaded part is going to be 12.34 centimeters squared, and that will be our answer. So you may as well also try out this number. You may try it out and see what answers you get. Chord properties of a circle. In our earlier videos, we defined what a chord is. A chord is simply a line that connects any 2 points of the circumference. So it can run from here up to there, or it can run from here up to there. Any 2 points of the circumference is connected by a line we call a chord. This is Kisembo Academy, and thanks for tuning in. We'll look at the first property of a chord. Looking at this, we are saying that the perpendicular bisector of a chord of a circle passes through the center and bisects the angle subtended by the chord at the center. We are having a chord here AB. So if we are having a chord AB, the perpendicular bisector of this chord will pass through the center. And this is the perpendicular bisector we are talking about. It means that when this line is coming, this perpendicular is dropped from the circle's center to come and bisect this line or divide it into two. It means that AD, which is that, is equal to DB. So this length is equal to that length. Since this perpendicular bisector bisects this chord, it means that this angle up here is the same as that angle. They're going to be the same. The line joining the midpoint of a chord, which is the perpendicular bisector we've talked about in the previous property, this line bisects this chord into two. Our right up here says that a line joining the midpoint of the chord to the center of the circle is perpendicular to the chord. So this is just a minor detail of our previous property, that this line that is going to bisect this chord into two is actually meeting this chord at 90 degrees, or call it a perpendicular bisector. So CD is perpendicular to AB, and therefore D is the midpoint of AB. And if D is the midpoint of AD, it means that this portion AD is equal to this portion DB. Next property says, if two chords of a circle are of equal length, then they are the same distance from the center of the circle. And in our illustration, we are having chord AB, we are also having chord DC. If these two chords are of the same length, it means that they are going to be having the same distance from the center. So it means the distance from here to here, FC, is the same as the distance from C to G. So it also follows that the distance from A to F is the same as the distance from F to B, and also the distance of D to G is the same as the distance from G to C. Now our next property is just the reverse of this. In our next property is telling us that if two chords are the same length, then they have the same distance from the center. So if we're having chord AB and chord ED, and these two chords are the same distance, so it means, they're the same length, then it means that the distance they are from the center is the same. And so in this case, FC is the same as CG. So we'll work out this example. Now, as we are interpreting some of these numbers, we need to interpret them basing on these properties of chords we have explored. Find the length of the chord of a circle of radius 5 centimeters, which is 3 centimeters from the center. So we are having a circle like this with a center. And now they're asking us to find the length of the chord. Let's say this is the chord. They want the length of the chord of a circle whose radius is 5 centimeters. So the radius of the circle is 5 centimeters and it is 3 centimeters from the center. So the distance from here to there is 3 centimeters. So the chord is 3 centimeters from the center, but it's having a radius. Remember, this radius, this distance from here to here is also 5 centimeters. The radius of this circle. This is the circle's center. So if they want us to find the length of the chord, we know that this, if you're to look at this and extrapolate it out, you find yourself having a right angle triangle. We said in our earlier properties that a line that is connecting, when you drop a perpendicular from the center of the circle to the chord, it is going to divide this chord into two. So if it is going to divide that chord into two, it means that the distance here is the distance here. So if we want to find the length of the chord, it's as simple as finding the length of this part, then we just multiply it by 2 to be able to get the entire length of the chord. So here we are having, this is 5 centimeters, this is 3 centimeters. For us to be able to get this length, let's call this length x. So we use Pythagoras theorem to get this length. X squared plus 3 squared is equal to 5 squared. So it becomes x squared is going to give you 5 squared minus 3 squared. We shall end up getting our value of x as 4 centimeters. When we get our value of x as 4 centimeters, it means the distance from here to here is 4 centimeters. But we are aware that this is half of the whole thing. So it means that the length of the entire chord is 4 centimeters plus 4 centimeters, which is 8 centimeters. So the length from here to here is 8 centimeters. That's the answer. Two parallel chords of a circle of radius 10 centimeters are of length 12 centimeters and 16 centimeters. Calculate their distance apart. Let's draw a sketch. We have a circle. Two parallel chords of a circle. So we have two chords that are parallel. We have the chord up there and the chord down there. They are parallel, so it means they never meet. Two parallel chords of a circle of radius 10 centimeters. So it means that if this is the center of the circle, the radius is 10 centimeters, are of length 12 centimeters and 16 centimeters. So if this thing here is 12 centimeters, this one down here is 16 centimeters. Calculate their distance apart. So if they want us to calculate their distance apart, this is the distance they want us to calculate. But now if the distance from here to the circumference is 10, it means also the distance from here, the radius, to the circumference here is also 10 centimeters. So if they want us to find the distance apart, it's a matter of getting this distance. We also calculate for this distance, and then we add the two distances, and we are able to find the distances apart, the distance between these two chords. But also we know that when you drop a perpendicular from the circle center down to this chord, this line is dividing this chord into two. So if this whole chord is 16 centimeters apart, it means that the distance from here to here is 8, and this one is also 8 centimeters. Likewise up here, if this whole chord is 12 centimeters apart, it means the distance from here to here is 6, and from here to here is also 6 centimeters. So in so doing, we are able to extrapolate right angle triangles, and our own task is to just find those two heights, and we are done. So if you are to extrapolate that, we have this one is 10, this one is 8, so we call this x. The distance from here to here, we call it x. Then also the distance from here to here, if we are to extract that as well, this is 10, then this is 6, and then we get this distance. Let's call that distance y. So to get the value of x, we are going to use Pythagoras theorem. X squared plus 8 squared is equal to 10 squared. So our value of x here is going to be centimeters. Likewise here, it's going to be y squared plus 6 squared is equal to 10 squared. So to get our value of y, it's going to be, so the total distance of the distance between these two chords, this distance is going to be x plus y, which is 6 plus 8, which is going to be intersecting chords. We'll study this diagram in front of us about these two chords that are intersecting. The intersecting chords we're talking about here in this case are chord AB and CD. These are two chords that are intersecting. Now when these two chords intersect, of course, now some of the properties that you should be aware of is, by common sense, you will know that this AD is a chord on its own. AD is subtending this kind of angle to the circumference. Then you're also having the same chord AD subtending an angle to that other circumference. So it means this angle and that angle is the same. So it means angle ACD is the same as angle ABC. Likewise, this chord CB, it is subtending an angle to the circumference, and this is also subtending an angle to the circumference, the same chord. So it means this angle here is the same as that angle here. It's the same when you look at it from this way. When this is also a chord. Remember, a chord is just a line that connects any two parts of the circumference. So when you look at this chord, it is subtending an angle to that point, and also this same chord subtending an angle to that point. So you find that this and that are the same. It is the same with this chord. It is subtending an angle there. It is subtending an angle there. So it means that this angle and that angle are the same as well. So this seeks to explain that BCD, which we've just talked about, BCD is equal to BAD is equal to BAD. These two are the same. Also ABC, which is ABC, this one is the same as that one, ADC. Same stuff. Then we have CPB, which is CPB is equal to APD. These two angles are also the same because they are vertically opposite angles. It's the same with this. This angle is also the same as that angle because this and that they are also vertically opposite angles. That is from our angle properties. Then since we've realized that this triangle is similar to that triangle, then it means that PC over PA is equal to PB over PD, because this triangle is similar to that triangle. It's the same with this one. This triangle also is equivalent to these triangles are similar. So that's how we interpret when the chords are intersecting in that kind of way. Looking at the next category of intersecting chords, we are having these chords running, but they are going out and they are meeting outside at X. These chords are meeting externally. And if you look at this diagram, we are having a line here. This line is parallel to that line. When this line is parallel to that line, it makes this triangle, which we are calling AXC, this triangle is similar to that triangle. Now, when this triangle is similar to that triangle, it means that XA over XB is equal to XC over XD. We deal with them like they would deal when we're dealing with figures that are similar. Now, please take note that these are only similar only if these two lines are parallel. We have another case whereby we are having a chord intersecting with a tangent. Now, this tangent, if you take a closer look, you will notice that it is having point A and B. Points A and B are still parts of the tangent. They are parts of the tangent, but they are very close. Part A and part B are too close to the tangent as it is passing by. And of course, here the R write-up says that if M is the midpoint of intersection of this AB, which is this line, and CD, which is that line, we are having chord AB, which is too small, and CD. When these lines AB and CD prolong and they meet at point M, when they meet at that point, and the thing is that A and B are so close, so much that they meet at T, then it means that ABM becomes TM. It means that this value of T is more of a representative point to represent A and B, since these A and B are too close to each other. So when these A and B are too close to each other to the point that we are considering to just consider it as one point as T, it means that now this ceases to become just MB, or it ceases to become MA, but it becomes MT. So we would still say that MA times MB is equal to MC times MD. But now since A and B are the same, then we shall simply say MT times MT is equal to MC times MD, just like we've done it here. That MA, from the first to the farthest, times from the first to the nearest, is equal to MC, which is from the first to the farthest, times MD, which is that MC times MD. And so when we write it, we do it like that, we end up with MT squared giving us MC times MD, just like that. Let's get to look at these two intersecting chords. We are having AB and CD right there. These two are intersecting at point M, and we are being told that two chords AB and CD of a circle are produced. They are produced to meet out at M, outside the circle. Now, given that AM is 8.4, so from A to M is 8.4, BM is 5 centimeters, MD is 10 centimeters. Find the length of MC. So we need to find the length of MC. We are still going to use the property we've just done before. So to find the length MC, we shall say M times A, MA, times MB is equal to MD times MC, and it is MC we are looking for. So what is MA? MA, or what we are calling AM, there is no difference, is 8.4 centimeters. So this is going to be 8.4 centimeters. Multiply that by MB, which is the same as BM, which is 5 centimeters, times 5 is equal to MD. Now from M to D is 10 centimeters, which is 10 times MC, which we are looking for. So MC. So the rest is math. So our value of MC becomes 8.4 times 5, divide all that by 10. And we get our value of MC as 4.2 centimeters. In our next question, you are required, we are being told that there are two chords, AB and CD, of a circle, and they are produced to meet the circle at T. So these two chords are produced to meet this outside at point T, to meet outside the circle. So they are produced to meet outside the circle at point T. We are being asked to find length TD. So we are going to employ the same technique. TA times TB is equal to TC times TD. So we begin working. So it becomes TA times TD is equal to TC times TD. Now our value of TA from T to A is 5 plus 4, which is 9, times TD, it is actually TB, times our value of TB, which is 4 centimeters, is going to be equal to TC, which is 9. Remember, we're looking for this length and we do not know it, so let's call it x. So from TC is going to be 9 plus x times TD. TD is x. So our task is to find the value of x. So we know that 9 times 4 is 36. Is going to give us, this is going to be, opening this bracket is 9x plus x squared. So when we transfer this 36 to move that side, we shall remain with 0 here, and we form a quadratic equation, x squared plus 9x minus 36. So when you solve that quadratic equation, we'll get our value of x, two values of x. One value of x will be 3, and the other value of x will be negative 12. Of course, we shall go with a positive value because distance is positive. So it means our value of x here will be 3.
This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.